Hello everyone. Thank you for joining this session. My name is Sohail Ahmed. I am the manager of the projects department. Today we will be demonstrating the features and benefits of ETAP Digital Twin Based Electrical Operator Training Simulator on behalf of ADNOC. During this presentation, I plan to introduce the project and its requirement and explain how the ETAP Digital Twin Based EOTS solution met the requirements for establishing a high-fidelity training system for the operation team. I will also highlight the value addition provided by ETAP, the technical capabilities, and finally a brief summary highlighting the key points and takeaways. First, I will give you an introduction of ADNOC and its facilities. The Abu Dhabi National Oil Company, also known as ADNOC, is the state-owned oil company of the United Arab Emirates, and it is the world's 12th largest oil company by production. It has 16 subsidiary companies in the upstream, midstream, and downstream stages of production. It operates on a series of islands in the Persian Gulf of the Abu Dhabi coast, which are isolated physically and electrically from the mainland. ADNOC is also committed to sustainability and has implemented various initiatives to reduce its carbon footprint, enhance operational efficiency, and support the UAE's goal for renewable energy and climate change mitigation. This is a brief about the ADNOC's facility where the electrical operator training simulator has been deployed. Das Island is integral to ADNOC's oil production capabilities and contributes significantly to the UAE's economy and energy security. Its operations support the global energy market while reinforcing the UAE's position as a key player in the oil and gas industry. It serves as a crucial hub for ADNOC's oil and gas operations, particularly for the production, processing, and export of crude oil and gas. The facility consists of a total 12 generators, which include steam and gas turbines, and has a total generation of 315 megawatt. These generators feeds power to the key facilities that support the extraction and the transportation of hydrocarbon resources of the island and provide power to two remote platforms that are connected to the island through subsea cables. Some of the key highlights of the project requirements. Why operator training is necessary for an independent power plant or any other electrical network. During the life cycle of an isolated plant, the operation team is required to be constantly trained and updated to get acquainted and adapt to the current electrical network, as well as get themselves trained on for the future upgrades, such as generation upgrade, adding of the generation, and adding to the load requirement. And to safeguard the operation of the complete plant to reduce the amount of downtime or disturbance. The challenge has been on how to provide training where the operators not only get familiar with the operation management tools and procedures, but also get the experience of the system response. For instance, it is common that operator can find a way to achieve the goal, but if it is not done correctly, precious time can be lost as a result. This can lead to loss of productivity, production, outages, fines, even injury or death. ADNOC intended to provide a training environment for the operations staff for the integrated and reliable operation of the existing power management system and its many modules to ensure that they are very well trained in the principle of electrical networks, turbines, and generators, and cope up with any operating scenarios that they face on a day-to-day basis and during a plant startup or a shutdown. or any kind of disturbance in the electrical network. The PMS applications include electrical energy switching and monitoring, which is also known as ESM, generation management system, which is GMS, which are controlling the various type of generator in the plant, which are of different make and model and having a different control function. Load management system, which is LMS, that takes care of the load shedding as well as load restoration and other functions of the existing PMS, such as alarming, trending, event recording. So the scope of work for the electrical OTS requirement in a brief are creation of a simulation system that provides realistic response to the operator action and reproduce the state and behavior of a live operational plant. Note that I have highlighted the realistic response because this is a key feature that can be very difficult to achieve in the industry. The scope also includes creation of a digital twin model of the electrical network with all dynamic parameters of the generators, motors, relays, etc. This also includes designing the HMI visualization similar to the existing PMS system so that the operators can be trained on on an environment which resembles their exact PMS. A brief about project objectives. The primary objective of the ETAP OTS is to improve the operator's competency by providing training and certification during the operation of the plant under different conditions, which includes normal operation, where the plant monitoring and control are covered, alarm management, generator synchronization and regulation, interconnected and islanded operation. In this plant, there are three different switch gears where the generators are available, and they are at different voltage levels because this was gradually upgraded. The generation of the system was gradually upgraded, and there is an interconnection between these three main switch gears. So it is very complicated in a day-to-day operation to interconnect and operate the plant as one island, as well as operating in multiple islanded operation. The OTS also has to provide training on equipment malfunctions, activation, deactivation of features of ESM, LMS, and GMS, operator actions and their impact on the electrical network, adjustment of the GMS system priority assignments. This is the project architecture where we have one trainer workstation where the PMS expert will be assigning the training sessions to the trainee workstations. In this project, we have three different training workstations which are connected to the single trainer, and there is an option to start the training session as a standalone. That means each individual trainee will have their own scenario to run and the training to perform, or it can be a team-based training environment where all three operators will be sitting in front of the HMI and they will be working as a team on the same scenario. These are the few highlights of the actions which can be performed by the trainer and the trainee. Trainer actions include starting a training scenario, operator actions, injecting trip signals for the training session, increase or decrease loading, creating islanding and interconnection conditions. Some of the trainee actions are protective equipment open close, transformer tap position change, GMS mode regulating set points, uh, generator mode and set points change, alarm management, load shedding management. From simulation to operation, EOTS utilizes the ETAP Digital Twin Foundation to provide operators, engineers with an effective learning environment to improve and augment their knowledge of the actual system. This is the key highlights where there is a comparison between the project requirement and the solution provided. Leveraging the vast knowledge of the electrical systems and analytical engines, ETAP Electrical Operator Training Simulator provides dynamic power model network, predictive simulations to verify proper switching, simulation and validation of sequence of operation, replicating the real-world situation with unlimited steady state and dynamic scenarios as a remedial action, and trainer to trainees learning evaluation environment. One of the major features that is unique to the ETAP OTS solution is system dynamic support. This is because the transient stability engine is utilized within the OTS simulator. This gives the trainees a very realistic window into how the system actually behaves. For instance, when there is a large transformer which is energized, the associated inrush can be seen in the operator screens. Another key feature is the fact that the relay protection model within the ETAP is taken into account by the simulator. For instance, if an overcurrent relay is modeled and it will automatically trip the breaker if the required current is detected. Dynamic response combined with the relay protection reveals critical information that many operators may not have known previously. Here is a quick architecture showing the flow of the information. In the center sits the instructor, which can receive real-time data from the existing SCADA system or a PMS system, historical data from the ETAP playback service, or simulated data from ETAP analysis. From here, the trainer can use this real-time, historical, or simulated data to initialize the trainee's environment. The trainee then can run through this training plan, performing operator actions, seeing the system response by the digital twin, all while operating on the various SCADA interfaces. Finally, the trainee actions are sent to the trainer for review. These are the key highlights of the OTS solution. Operator training on the vast power application simulate circuit breaker operations, identify potential operation problems, predict system response based on the operator actions, perform what-if operation scenarios. Here are some views which has been delivered for this project. On the left, you can see the existing PMS screens. On the right, we can see the OTS screens, which exactly replicates the HMI of the PMS for training sessions. Some key highlights. Reliable EOTS high fidelity model using ETAP digital twin platform to provide dynamic simulation for the project system-wide plant operation. Competence. It improves the operator competency, confidence, and knowledge for better plant operation. It is flexible. Virtual training using ETAP platform allows to reproducing realistic plant behaviors with identical power system operational environments. It is configurable, easily and quickly configurable in the OTS setting, where you can define where an ad hoc scenario can also be defined, or a predefined configuration can also be used for a training session. And there is no limitation on creating the number of scenarios for the training. It is affordable. It has substantially reduced the cost of the training simulator as it has reduced the dependency on the hardware, which gives a very fast response for any operation. This OTS solution is completely based off of software, which is software in the loop, which is providing the same exact fast response, and it is affordable for the deployment at the site as it takes very minimum space. It is easily maintainable. During the plant life cycle from design to operation phases, it improves productivity and efficiency. This tool can also be used to evaluate uh, the upgradability of the system. It can also take care of the change management where we can define uh, addition of addition of some generation or loading, and that can be verified. Operation management, engineering efficiency, and it serves more than a trainer. This helps prepare the operators to respond to any malfunction and emergency and keep them ready for the real-time operation. The predefined scenarios for operator coaching and self-training helps the operation team to perform multiple exercises before facing the real environment. The training simulator provides the capability to inject events, messages, and disturbance under various operational situations by the trainer during any exercise so that they can evaluate the new operators on the basis of they how fast they react to maintain the system stability. So thank you. It was a pleasure having you in the session. I hope you found it insightful. Thank you.